They could be called exoplanets, two worlds with such extreme conditions they make the wildest in our own solar system seem normal by comparison.
The Hidden Universe Showcase explores exciting new results in infrared astronomy from NASA's Spitzer Space Telescope, with your host, Dr. Robert Hurt.
Our Earth is really a pretty pleasant place compared to the other planets in the solar system. Even the hottest day in the Sahara Desert is downright chilly compared to the molten lead temperatures on the surface of Venus. And the worst Category 5 hurricane? It's hardly a dust devil next to the Earth-sized cyclones in the atmosphere of Jupiter.
Could there be other worlds out there with even wilder weather than we see in our solar system? Astronomers using NASA's Spitzer Space Telescope think they found two that are all that and more.
Instead of exoplanets, let's call these exoplanets because they have the most extreme conditions we've ever seen. Their official names, HD 149026b and HD 189733b, are based on the catalog numbers of their host stars. Personally, I'm going to call them something unofficial but easier to remember: Cyclops and Storm, the hottest and windiest known planets.
Both of them are so-called hot Jupiters, a class of gas giants like the outer planets in our solar system. But their orbits would fall well inside that of Mercury, and that makes them hot. It also makes their years short, taking only 2 or 3 Earth days to orbit their stars. Our first exoplanet, Cyclops, can be found in the constellation Hercules, orbiting a sun-like star that's about 250 light-years away.
Its day side is a blistering 2,300 degrees Kelvin, according to infrared Spitzer observations made by astronomer Dr. Joe Harrington and his team. That's a lot hotter than the inside of a blast furnace, and sets the record for known planetary temperatures.
If we could actually see it, this Saturn-sized world wouldn't look like anything in our solar system. To reach such a high temperature, astronomers calculate that its atmosphere must absorb nearly all the radiation from its nearby star.
It's probably as black as this lump of coal. The only light from it would be the thermal emission from its sunward-facing hotspot. Cyclops may indeed look like a giant black eyeball with a glowing iris.
A little closer to home, our other exoplanet, Storm, can be found in the constellation Vulpecula at a distance of 63 light-years. A team led by Dr. Heather Knutson carefully studied how Storm's brightness varied over the course of its orbit and derived the first ever temperature map for an exoplanet. Unlike Cyclops, where the hotspot sits directly under the baking heat of its sun, on Storm it's shifted away by about 30 degrees. The researchers deduced this shift is caused by ferocious winds in the upper atmosphere that sweep the hot clouds around the planet before they can cool off much. The wind speeds could be as high as 9,600 kilometers an hour, or 6,000 miles an hour. That's about 30 times faster than the jet streams in Earth's atmosphere.
Storm's day side is about half as hot as Cyclops, but its night side only drops a couple hundred degrees due to the winds redistributing the heat.
So how can we gather weather reports from worlds we can't even see directly? They're so far away their faint glow is completely blurred together with the much brighter light of their host stars.
It's like trying to study a tennis ball that's next to a searchlight. That's 100 miles away using binoculars. Fortunately for astronomers, both Cyclops and Storm are transiting systems. Their planetary orbits are aligned nearly edge-on along our line of sight. When they transit in front of their stars, we can learn a lot about them by measuring how much starlight they block.
But while stars are brightest in visible light, planets emit most of their light in the infrared. Proportionally, this makes a big difference. They may still only account for less than 1% of the total light of the system, but amazingly, That's enough for Spitzer's infrared detectors to measure.
These measurements are making astronomers the first interstellar weathermen. The 2007 record highs go to Cyclops, and the record winds were logged on Storm. But records seldom last, and exoplanetary weather is a young field. Fortunately, Spitzer will remain a powerful tool for studying exoplanets even after it runs out of coolant at the end of its primary mission. Expect to hear about hotter, windier, and even stranger exoplanets in the coming years. For the Spitzer Science Center, I'm Dr. Robert Hurt, reminding you there's a hidden and extreme universe just waiting to be discovered.
The Hidden Universe is produced by the Spitzer Science Center at the California Institute of Technology in Pasadena. The Spitzer mission is managed by NASA's Jet Propulsion Laboratory.
Cyclops and Storm, the hottest and windiest known planets.